let us start with vector curl, or the operation curl. So let's see how we can define this operator curl. So for that, if you suppose your vector to be, if suppose your function or the vector f of x, y, z, that is defined to be f1 I cap plus f2 j cap plus f3 k cap. In that case, this is the vector. Okay, so this is the vector that is given to us, and then we can define the curl of this vector f. Then the curl of this vector f, that is defined by del cross vector f. So that means here we have to take the cross product of the vector, this operator del with the vector f, or we can write this to be curl vector f. And by definition, this quantity is equal to taking the cross product of del by del x I cap plus del by del y j cap plus del by del z k cap, this vector cross with the f vector, that is f1 I cap plus f2 j cap plus f3 k cap. And how do you compute the cross product of two vectors? It is simple. You just have to evaluate the determinant with here the I cap, j cap and k cap, then the coefficient of I cap, j cap, k cap for the first vector, so that is del by del x, del by del y and del by del z, and then you have to write the components of vector I, j and k for the second vector, that would be f1, f2 and f3. So when you evaluate this determinant, what value would you get? For I cap, you will obtain this thing, right? Now whenever you multiply these two quantities, you can write del by del y of f3, but you cannot write f3 del by del y. Why? Because this del by del y, this quantity is a operator here, right, and not a function. The function is f3, so the order should be only this. You cannot reverse its order. So here for I cap, when you multiply these two quantities, so it would be del by del y of f3 minus del by del z of f2. Then the components for j, so we have minus j cap, then del by del x of f3 minus del by del z of f1, and then plus k cap of the quantity this one, del by del x of f2 minus del by del y of f1. So this is the curl of a vector f. Now if you notice here that after doing this curl here, when you perform the curl operator on the vector f, so that means you are inputting a vector here, and as a result you are getting a vector here, right, because it has the components unit vector I, j and k. So that means curl of a vector point function, this is to be noted, of a vector point function is also a vector point function. That is also a vector point function. So this is to be noted here. If you remember, the we earlier used to take gradient of a scalar quantity, and that comes out to be a vector, and we took the divergence of a vector quantity, and that came out to be scalar. But in this case, we perform the curl of a vector quantity, and in effect that comes out to be a vector, right? So let me give you some examples here. So let's see the example. First example is, we are to compute, so here the question is, find the curl of the vector f, which is defined like this: x y square I cap plus 2x square yz j cap minus 3yz square k cap. So this is the vector that is given to us. So in order to perform the curl of this vector, so what you are to do, you are to calculate del cross vector f. So this is basically I cap j cap, k cap, and then the quantities for this operator del, that would be del by del x, del by del y, del by del z, and then the quantities for the vector f, that are x y square, 2x square yz, and they are minus 3yz square. So you have to compute this determinant. So for I vector, you are to perform del by del y of minus 3yz square, this quantity here, and minus of performing this, right, del by del z of 2x square yz. So this is corresponding to I cap. For j cap, we are to take the product this, so that means we'll apply del by del x over minus 3yz square, right, minus we'll apply this over this, so it would be del by del z of x y square, and plus k cap. For k cap, you have this quantity with this quantity, so del by del x of 2x square yz minus del by del y of xy square, right? So here, when you solve this, when you take out the partial derivatives, in this case, we are taking partial derivative with respect to y. So here x and z are constants. So that means we have minus 3z square. For the second quantity, we have 2 minus 2x square y, right? And this is for I cap. For j cap, we have here there is no x, so this quantity is 0, and here there is no z, so this quantity is also 0, right? And for the k cap, we are to take derivative with respect to x partial, so it would be 4xyz, and when you take it with respect to y, so it would be minus 2xy. So this is your curl calculated at for the vector f. So the values are minus 3z square minus 2x square y into I cap. There is no term consisting of j cap, so we have plus 4xyz minus 2xy into k cap. So this is the curl of the corresponding vector. So for this physical significance of this vector curl, what does it physically represents? So let's see that.